This video shall demonstrate the interactions with the Prolix system using two example predictions for the opening weekend growth. Please refer to the textual submission for details about the individual views of the system. The first example is Now You See Me. We select the prediction candidate movie from a list of soon-to-be-released movies or by entering its name in an autocomplete box. As soon as the movie is recognized, the other views load and present their appropriate data. In the view for selecting related movies, we use the metadata of IMDb to connect the movie to related ones. Using the plot keywords, we receive a ranked list of similar movies. Here we find other heist plots such as Dark Knight and Ocean's 11, and magic shows like The Illusionist or The Prestige. We complete this list by manually adding other parts of the Ocean series and the Mission Impossible movies. This selection now helps us to better judge the outcome of our machine learning-based predictions. In the view for parameterizing and evaluating the machine learning-based predictors, we use the default configuration for an initial prediction. However, the resulting predictor has used only 19 training instances and displays very poor error measures. We now can use different features that exclude fewer training instances due to missing values. In the feature selection view, one column depicts how many instances we lose by using a certain feature. We deselect all Twitter features in order to train an additional predictor on the large IMDb dataset and another one with additionally deselected frequently missing attributes like writer. Alternatively, we can fill in missing attributes in the training set by using a median value. These new predictors have much better error measures, but miss the insights of the Twitter data. We therefore train two more predictors using a combination of Twitter features and frequent IMDb attributes, as well as solely using the Twitter features. To help analysts in choosing a final prediction, we included a combination predictor calculating a weighted average of selected base predictors. Here, analysts can adjust the weight of each predictor based on their contextual knowledge and the resulting error measures. The second example is The Conjuring, showcasing an interesting Twitter behavior. We already have selected the candidate movie and some related movies for reference. If we train with only IMDb data, The Conjuring is predicted extremely low. However, the Twitter-based prediction evolution forecasts an excellent income for the horror genre. We try to understand this difference by inspecting the attribute value distribution of certain prediction ranges using a vertical lens in the actual versus predicted scatter plot. Here we can see that The Conjuring shares a low budget and the partially inexperienced cast with other low predicted movies. Deselecting these features indeed increases the prediction value. The Twitter volume of the movie has a distinct peak on Tuesday. We first try to rule out hype artifacts by excluding retweets, allowing only one tweet per user and day, and using only tweets classified as positive interest. The peak remains, and an examination of the related word cloud reveals a strong want to watch and scary opinion. We restrict the set of messages to those containing the word trailer and see that there was a quite successful trailer commercial on the television. Using this knowledge, we create predictors comparing these dynamic message counts amongst the movies and again create a final combination predictor. Due to the Twitter-related insights, we add more weight to the Twitter predictors for our final score.